Hello, Precal. How is everyone doing today? We're going to be talking about functions again. Here we're going to be talking about determining domain and intercepts from an equation. So let's read through this real quick. If the domain of a function in an equation, in equation form is not expressed, meaning they just don't flat out tell you, it's implied to be the largest set of real numbers that have a real output. So basically, don't break any of the big laws. No dividing by zeros, no square root of negative numbers, all that jazz. When determining the implied domain from an equation, there are only three expressions that can cause restrictions. If it's not one of these three, we call them the big three. If it's not one of these three, we don't worry about it. The first one is if you have a fraction, because we know you cannot divide by zero. The second one is a square root, because we know that you cannot take the square root of a negative number. That's why a has to be bigger than zero here. The third one, we're going to get into this a little bit later this year, logarithms. If you're taking a log of a number, that number has to be bigger than zero. You'll see why later. Obviously, other restrictions can be implied by real world stuff, like if you're talking about gallons of water that a tank will hold. It's not going to be negative, right? Stuff like that. So, for each of the following, determine the domain and the intercepts from the equation. This equation is not one of these three, so your domain is all real numbers. There's a shortcut to write that. It is an R with two backs. X-intercepts, we set y equal to 0. So your x-intercept here, 0 is equal to 5x squared plus 4x minus 1. Alright, if we factor that, factoring you should remember from Algebra 2, Algebra 1, if we need help, I'll help. But factoring that, you get 5x minus 1 and x plus 1. Solve for x, add 1, divide by 5, you get x is equal to 1/5. Subtract 1, you get x is equal to negative 1. So we've got two x-intercepts. We've got 1 over 5, comma 0, and negative 1, comma 0. Y-intercept, set x equal to 0. Y is equal to 5, 0 squared, 4 times 0, minus 1. Everybody loves these. These are the easy ones. 0, negative 1. Alright? Domain, 3x over x minus 5. Is this one of these situations? That's what I'm looking at. Is this one of these situations? Yes, it is. It's the first one. The bottom cannot be 0. X minus 5, go ahead and write it, cannot be 0. So where does that happen? X cannot be 5. Add 5 to both sides. Plus 5, plus 5. There's your domain. X can't be 5. Easy peasy. X-intercept, set y equal to 0. I'm going to keep writing this until it's drilled in your head. 0 equals 3x over x minus 5. Now if you multiply this side by x minus 5 and you multiply this side by x minus 5, isn't that just going to give you 0 equals 3x? Divide by 3 and won't you get x equals 0? So your intercept is 0, comma 0. Y-intercept, set x equal to 0. Y equals 3 times 0, 0 minus 5, 0 over negative 5. So again, 0, comma 0. That's really all there is to it. Domain, is this one of our situations? Yes. What can we not take the square root of? A negative number. So look at where it's negative. So in other words, where will x plus 4, what's underneath the square root, where will it go negative? I need it to be bigger than 0. Positive, right? I need it to be positive. What do you need? I needs the positives. So, subtract 4. X is greater than negative 4. Domain. Easy. Done. Intercepts. Y equals 0. 0 is equal to the square root of x plus 4. Some of y'all might be a little rusty on this. Square both sides to get rid of the square root. 0 squared is still 0. X plus 4. Subtract 4. So your intercept is negative 4 comma 0. Y-intercept, set x equal to 0. Again, I'm going to keep saying it. Y is equal to square root of 0 plus 4. Y is equal to the square root of 4. Y is equal to 2. There's something special about this one here. We'll get into this a little bit later in the year as far as when do I keep a positive and negative in front of a square root sign. Remember, that's only going to be when you're trying to get rid of a square root. So for here, it's just 2. All right? Let's keep going. Getting this thing cranked out. This will be probably 11 minutes or so. Using function notation, f of x equals x squared minus 2x. Very simple. Whatever the value is in for x, you plug that in for x. Okay, whatever this value is, here it's negative 3. So I'm going to take and I'm going to plug in with parentheses negative 3 squared minus 2 negative 3. Solve it, or simplify it rather, simplify it. Negative 3 squared is negative 3 times negative 3, which is 9. Negative 2 times negative 3 here, plus 6. Negative times a negative is a positive. So f of negative 3 is 15. Negative f of x, very simple. You put a negative on the outside of it. Bam. If the negative's on the outside of f of x, put it on the outside of everything. Very simple. Simplify it, distribute your negative. Negative x squared plus 2x. Done. Negative is inside. That means that you only put it in for x. So negative x squared. Let me fix how I write that. Minus 2 negative x. Now this one can be a little more tricky just because of this negative x squared. If I square negative x, like if I put negative x times negative x, isn't that really a positive x squared? Yeah. Negative times a negative is a positive. Same thing here. Negative 2 times a negative x is a positive 2x. Now let's say you plug in x minus 3. What have we done so far when we plug in something for x? Just plug it in. X minus 3 squared minus 2x minus 3. See, what I plugged in here for x, I'm going to plug in for x up here. All right? Now this one gets a little more complicated because x minus 3 squared is really x minus 3 times x minus 3. Then we can simplify this. Don't forget your negatives. So that's negative 2x and 8 plus 6. Negative 2 times negative 3 is positive 6. Simplify this. Foil it, if you will. X squared, right? You got minus 3 and a minus 3. Minus 6x plus 9 minus 2x plus 6. X squared minus 8x plus 15. All right? We're going to keep going. All right? So what I want to ask here is this the same thing as this? Is f of x minus 3 the same thing of f of x plus f of negative 3? In other words, can you distribute entire functions by themselves? Okay, so f of x is this. F of negative 3 is 15. This minus 3. So we already have all the work done. It's saying, is this plus 15, is this equal to f of x, which is up here, x squared minus 2x, plus f of negative 3, 15. Are those the same? No! You got a negative 8x and a negative 2x. No! Here's what you write. Functions do not distribute. Bam! Functions do not distribute. Okay? Never, ever, ever. So answer the following questions about the function f of x is x minus 3 over x plus 2. What's the domain? The domain down here, what can x not be? Well, we know it can't be 0 down here, so x plus 2 cannot be 0. Subtract your 2, subtract your 2. X is not negative 2. What happens if you plug in a negative 1? F of negative 1 plug it in, see what happens. Negative 4 over 1. Or just negative 4. What point is on the graph of f? What point does this represent what we just did? We put in an x, we got a y, so our point is negative 1, 4. Where does f of x equal